This is a demo of creating custom automated AI evaluators for AI models or projects using a free tool called Kiln AI. Let's jump right in. The first thing we have to do is create a task. I've used the joke generator example from the app, and it generates a joke given a topic and a subject. The key thing to note here is that in the requirements section, we've created 3 requirements. The joke should be on topic, be clean, and be funny. We'll create that. And now we can hop over the run screen and see that it works. Great, it works. Let's jump over the Evals screen and create a new evaluator for this task. As you can see, we pre-filled the evaluator template from the task we earlier created. It's got the 3 requirements we defined, the rating types, and a new overall rating from 5 stars. We can just click create on the defaults to create a new evaluator. Now we have an evaluator, but we need some data in our eval data sets. Let's pop over to synthetic data generation and use Kiln's synthetic data generation tools to generate an eval data set. Okay, I've created 200 dataset samples across 10 topics, and it only took about 3 minutes of work using Kiln's synthetic data generation UI. If you want to learn more about this process, check out our other video in our docs about synthetic data generation. I'll click Save to generate the final results. Great, and now we'll head over to the Dataset tab, where I'll split this new dataset into 2 sub-datasets for evaluations. One for the primary eval, and a second 20% will reserve for the golden dataset. And finally, I filtered it down to our golden data set. And now I'll go through those and add some human ratings, which we're going to use as benchmarks when we actually test our evaluators. All right, now that we've got a rated golden data set, we can jump over and try to find the best evaluation method for the eval we created. So we're going to add an evaluation method. And that's basically exactly how an evaluator can run. And you've got a bunch of options here. The first is the algorithm. If you can use LLM as judge, which is exactly what it sounds like. A language model will evaluate based on the rubric you created earlier. Or G-Eval, which is a slightly fancier version of LLM as judge, where we look at the token output probabilities and weight it based on that. So if the model's halfway in between 2 options, you'll actually get a weighted result from those. You can select the model that you want to be the judge. And we add some properties, a description, and a series of evaluation steps. The evaluation steps are going to be used during chain of thought thinking before the judge model outputs an evaluation score. And you can see we've pre-populated these based off those requirements you created at the very beginning, as well as a weighted priority at the end. So let's create that eval method. All right, I've repeated that process and created a bunch of different competing evaluation methods for this eval. Some are closed models, some are open models, some are G-Eval, some are LLM as judge. We've even got local models running on a llama. So we can kick that off and wait for the results to come in. Great, and now that that's done running, Kiln has created a table showing how well each eval method compares to the human benchmark we created earlier. This is using correlation coefficient called Kendall's tau, but you can use Spearman or mean squared error or several other options here as well. And we can compare how each result did. Unsurprisingly, the really small models like Gemma 2 billion didn't do particularly well, having very little correlation to human scores. But some of the larger models like Sonnet 3.7 and GPT-4o using the G-Eval algorithm did particularly well. So GPT-4o is our winner, just edging out Claude 3.7. So we'll set that as our default evaluation method for this eval. All right, now that we've got a good evaluation method, we can use it to find the best method for running our task. And a run method is simply a pair of a prompt and a model that can be used to run your task. I'll create a bunch of these run methods that we can compare. All right, I've created a range of run methods to try. We've got large models, small models, remote models, local models. We've got a range of prompts like chain of thought prompting, basic prompting, multi-shot prompting. And I've even added in some fine tunes, which are models I created using Kiln specifically designed to perform well in this task. So now that we've got all these queued up, I can just kick off this eval, which will run with the remaining 80% of the data set we set aside to compare run methods. All right, 1,700 runs later, we've got a table showing how each run method performs on our task. There's some interesting insights in here. 5.4 really can't perform well in this task and is beaten by much smaller models like Gemma 2 billion. Models like Sonnet 3.7 predictably perform pretty well, but Claude 3.5 Haiku, which is a much smaller model and a little bit older, actually outperforms Claude 3.7 Sonnet on this problem. Looking at some models where we run the same model with different prompts, we can see chain of thought prompting has actually a nice little bump in performance, so we might want to use chain of thought prompting. And the second highest performing model overall in funniness and essentially tying Sonnet 3.7 is actually an open model we fine-tuned, Lambda 70 billion, fine-tuned with Sonnet outputs. So it's a distillation of Sonnet 3.7 thinking. It's our own reasoning model we built during the fine-tuning process. And with those insights, I was able to kick off a couple more fine-tunes using Haiku chain of thought data. And I was able to produce a Llama 70 billion model that performs better than Sonnet and almost as well as their state-of-the-art Haiku, and even a Llama 8 billion model that outperforms Llama 3.3 70 billion untuned. So you can picture iterating on this and finding the best possible approach for your task. And once you're complete, you can revalidate everything with a withheld validation set. And one last thing. We've been looking at the evaluator for overall task performance, but you can build your own completely custom evaluators or use a number of templates that come built in, like toxicity, bias, maliciousness, factual correctness, and jailbreaking. And these templates include evaluation steps using industry standard techniques, like this example from the bias evaluator. We even include templates for adversarial synthetic data generation, like this jailbreak template, where you can actually generate content designed to break your model and use evals to make sure it can't be broken. You can use it with uncensored and unaligned models like Dolphin. And that's the new eval toolkit from Kiln AI. You can download Kiln AI completely for free from GitHub now, or use our open source Python libraries to implement all of these tactics and code. I hope you enjoyed it. Thanks for watching.